Hi guys, so before we start our lesson on 6.3, the cosine ratio, I want to talk quickly about our triangle toolkit. So what our triangle toolkit is all the tools that you need to solve problems involving right triangles. Okay, so here we have a right triangle, let's call it ABC. Okay, so here our hypotenuse, so across from our right angle is C, here this leg is A, this leg is B. Now we already know we have our Pythagorean theorem, so a squared plus b squared equals c squared. So here, this formula is part of our toolkit. And then we have sine, which we did last class. So sine is opposite over hypotenuse, the ratio of my opposite side divided by my hypotenuse. Now, if I take a look at one of my angles here, so let's take a look at angle B. So the side opposite angle B is the opposite side here. The side opposite the right angle is, of course, our hypotenuse. And the side next to angle B, that is not the hypotenuse, so this one is our adjacent side. So adjacent, remember, means beside. Okay, so sine is the ratio of the opposite over the hypotenuse. What we will be going into today is cos. So cos is going to be the ratio of the adjacent side divided by the hypotenuse. And tan is what we will do after cos, and that is going to be the opposite side divided by the adjacent. Okay, so we have Pythagoras. We also have what we call SOHCAHTOA. So SOHCAHTOA, which tells us what our ratios are. Okay, remember we can only use Pythagoras if we have two sides and we're looking for another. Anytime we have an angle on just one side, we need to use either sine, cos, or tan. So today we're going to look into cos. Okay, the cosine ratio. So like we just said, the cosine ratio is the length of our side that is adjacent to an angle divided by the length of the hypotenuse. Okay, so let's just pick an angle A here. So here's A. Now, the side adjacent to A is right here. This is my opposite side, and here is my hypotenuse across from my right angle. So the cosine ratio uses our hypotenuse and our adjacent, and it completely ignores the opposite. Right? So using a calculator, we are going to determine the following cosine ratios, and we will round those to 4 decimal places. So grab your calculator out, and along with me, making sure you're in degrees mode, not rad or grad. So cos of 15. So cos 15, and we get 0.9659, and we won't be rounding that 9 up because it's a 2 after. So 0.9659. Okay, cos of 60, once again, cos 60, get exactly 0.5. Cos of 30, and we get 0.866, then 0, or just 0.866. We'll do 0 there. And then cos of 80 degrees. So cos of 80, 0.1736. So what your calculator is doing, cos of 15, anytime you have any triangle that has a 15-degree angle, the ratio of its side adjacent divided by its hypotenuse is going to be 0.9659 every single time. Doesn't matter how big or small the triangle is. If that angle is 15, it will always have a ratio of adjacent over hypotenuse of 0.9659, so on and so forth. Okay. So example, we're going to calculate the missing side lengths, and we're going to round to 1 decimal place. So here, if we remember our steps from last time, with our sine ratio, we want to label our triangle first. So here's my angle. Here, across from my right, my 90-degree angle, the right angle, that's my hypotenuse. Here, this one is my adjacent, next to this B, and here across from it, that would be my opposite. Now, once again, this next step is important once we start having different ratios. So for this lesson, we're only dealing with cos, so step 2 is kind of moot. But we're going to circle 3. Circle 3 things. So 2 things that we know and 1 thing that we need to find. So circling 3, I know my hypotenuse, I know this angle, and I want to find this adjacent side. So circling adjacent and hypotenuse, this would let me know that I'm going to be using my cosine ratio if I wasn't on a cosine ratio lesson right now. Okay, so third step, we're going to write our ratio. So the cosine ratio, in this case for B, is going to be its adjacent side divided by its hypotenuse. So adjacent divided by hypotenuse. And then substituting in our numbers. So cos of 33 is going to be our adjacent, which is x, we need to find, divided by our hypotenuse, which is 9.6 inches. Now, I'm going to show you a way that's a little bit different for solving this than last time. So WAM10 is basically proportions 101. So if we want to turn this into a proportion, because we know how to deal with proportions, I can just put this cos of 33 over 1. It's still cos of 33, and now it looks like a proportion. Now remember, when I'm solving for proportions, okay, so let's take a look. I will divide by the one across from the one that from the box or square that I'm looking for. So I will divide by the 1, and I will multiply the other 2 together. So how I will solve for x here is I will do 9.6 times cos of 33, and then divide by 1. But if I dividing by 1, it's just going to be the same number, so I don't even have to write that. I could, but I don't have to. Okay, so remember from our sine lesson, try to write 9.6 out in front instead of behind. It's just easier when we put it into our calculator. It just makes less mistakes. So in our calculator, 9.6 times cos of 33. And we get 8.0512, so on and so forth. So 8.0512, and then we're in inches, and we will round that to 1 decimal place. Okay, so here, run decimal places there, take a peek over the wall. We're going to have to round that up to 8.1 instead of 8.0. So 8.1 inches. Okay, so after substituting in, we solve, and then don't forget units. All right, number 2. So first step, label. So here we have angle A. This would be opposite angle A. Here is our hypotenuse. Here is our adjacent side. Now, I know it's going to be cos, but we're going to circle 3 anyway. So 2 things that I know. So I know my adjacent side, and I know my angle, and I'm looking for my hypotenuse this time. So adjacent and hypotenuse using cos. So cos of angle A is going to be my adjacent divided by my hypotenuse. So cos of 49, because that's my angle, equals my adjacent, which is 7.8, divided by my hypotenuse, which is x. Sorry. Now, turning it into a ratio, and this is what I'm solving for. So dividing by the 1 across, and I will multiply these 2 together. So 7.8 times 1, which is 7.8, divided by cos 49. So x will equal 7.8 times 1, which is 7.8, divided by cos of 49 degrees, which is, if we get out our calculator, 11.8891, so on and so forth, centimeters, or to 1 decimal place. So cutting off here, take a peek over the wall, 11 point, and I'll have to round that up to 9. So 11.9 centimeters is what x equals right there. So x equals 11.9 centimeters. Okay, last example for our first page here. So here's our angle. Let's label. So here's my opposite. Here's my hypotenuse across from my 90-degree angle, and last one's our adjacent side. Circling 3, circling hypotenuse. I know this angle, and I'm looking for this adjacent side. So circling adjacent and hypotenuse, I am going to be using cos, of course. So cos of my angle is going to be my adjacent divided by my hypotenuse. Substituting in, so cos of 12 degrees equals my adjacent, which is x, divided by my hypotenuse, which is 8.4. Turning that into a ratio or proportion. I will multiply these two, divide by the one across from what I'm looking for. So x will equal cos of 12 times 8.4 and then divided by 1. So x, so writing the number first, so 8.4 times cos of 12, and then I don't really need to write divide by 1 because it's just giving me the same number. So 8.4 times cos of 12, and I get 8.2164, so on and so forth, centimeters. Then rounding that to the nearest tenth, take a peek over, stays the same. Get out of here. So equals 8.2 centimeters. Danskis. Okay, next page. So solving the following problems, drawing pictures to support our answers and find the unknown. Now, first off, there's a problem with our question because this is a house and a house is not 40 inches long. This should be 40 feet. So one tick, or we're just going to write feet in here actually. Foolish picture. Okay, feet. So how far from the base of a house is a 40-foot ladder if the angle of elevation is 72, and there should be a degree sign there. So 72 degrees. All right, so first step, same thing. We have a picture. Let's label our triangle. So here is our triangle that the ladder is making with the house. Our ladder is 40 feet long. Here's my angle. So the height that it reaches is opposite. Okay, here I have my adjacent side, which is the distance the ladder is from the house. And here is my hypotenuse, which is across from my right angle. Right, so circle 3. So 2 things that I know, 1 thing that I don't. So I know this angle, I know this hypotenuse, and I am looking for how far from the base of the house is the ladder. So I am looking for the adjacent side. So adjacent and hypotenuse, I'm using cos. So writing our ratio, cos of our angle is going to be adjacent divided by hypotenuse. Substituting in, cos of 72 is my adjacent, which is b in this case, divided by my hypotenuse, which is 40 feet. Okay, writing it as a proportion. So here's d, what I'm trying to find, so I'll divide by this one and multiply the other two. So 40 times cos of 72 divided by 1. So 40 times cos of 72 degrees. And putting it into your calculator. We get 12.3606, so on and so forth, feet. So it's 12 feet from the house, basically. And since this is a word problem, we are going to answer the question with a sentence. So the ladder, and we will round to 1 decimal place, is about 12.4 feet from the house. If you want to be super picky, you could say base of the house, but I don't really care. Okay. Next question. A guy wire is attached to a pole. It's a guy wire, you say. So here's our pole. Here, let's say it is a flagpole. That's Maple Leaf. Okay, obviously. So a guy wire is a wire that is holding a pole in place. So a guy wire is attached to a pole. The wire is attached to the ground 12.5 meters away from the base of the pole. So 12.5 meters away from the base. The angle it makes with the ground is 52 degrees. So the angle the guy wire makes with the ground, so here's the ground, here's my guy wire, this is 52 degrees. And I want to know how long the wire is. So anytime we have a word problem, I am going to require you to draw a picture. So here, first step, here's our picture. Now, same thing. Now that we have our picture, I can see where my triangle is. We are going to label our triangle. So here's my angle. This is opposite my angle. Here is my right angle. So this is my hypotenuse. And this is my adjacent side. Next step, we're going to circle 3. So 2 things we know, 1 thing we don't. We know this angle. We know this side, our adjacent side, and we want to know what our hypotenuse is. So circling A and H, I'm doing cos. So cos of our angle, let's just say A, equals my adjacent divided by my hypotenuse. Substituting in, so cos of 52 degrees equals adjacent, so 12.5 divided by my hypotenuse, x. Turning it into a proportion, here's my thing I'm trying to find. So I will be dividing by cos 52. So to find x, I will be doing 12.5 times 1 divided by cos 52. There we go. So 12.5 times 1, which is 12.5, and then divided by cos of 52. If you remember the trick from last day, if you have x on the bottom, you can just swap them out, which is what we end up doing here. But we use proportions all through WAM10, so may as well keep using them. They're good for everything. You're going to use them till the day you die. So putting that into our calculator, we get 20.3033, so on and so forth. Rounding to 1 decimal place, we'll get 20.3. And our units here are meters. So 20.3 meters. Now this is a word problem, so let's write our sentence. So the guy wire is 20.3 meters long. There. Our last example, we have a screw conveyor, which is sometimes used to move grains and other materials up an incline. So how far from the base of a barn must a 20-meter screw conveyor be placed if the angle of elevation to the loft of the barn is to be 30 degrees? Okay, so let's draw a barn. So drawing our picture is always our first step. Here's a loft. Here's our conveyor belt. Here's a hay bale moving up. Off you go. Okay, so this angle needs to be 30 degrees. Remember, angle of elevation, horizontal up. So 30 degrees. The screw conveyor, sorry, is 20 meters long. Jeez. And I want to know how far from the base of the barn it needs to be set. So looking for our side here. Next step, label. Okay, so here's my angle. So this is opposite, the side opposite my angle. Here's my hypotenuse across from my right angle, and this is my adjacent side. Circling 3, so I know this angle. I know my hypotenuse. I'm looking for the adjacent, so adjacent and hypotenuse, I will be using cos. So cos of my angle, and I'm just going to substitute right in here. So cos of 30 degrees is going to be my adjacent, which is x, divided by my hypotenuse, which is 20. Skip the writing out step. Okay, so turning this into a proportion, because proportions are awesome. So here's my x, I'll be dividing by that guy, multiplying the other two. So 20 times cos of 30 divided by 1. So x, 20 times cos of 30 degrees, and then dividing by 1 doesn't really do anything, so I can just write that because I'm a lazy mathematician. So doing this calculation, and we get 17.3205, so on and so forth. And our units are meters, rounding that to the nearest decimal place. I would get 17.3 meters. And as a sentence. So the conveyor should be placed 17.3 meters from the base of the barn. Okay. Now, what I would suggest is to just at the top of every single one of your pages, just have SOHCAHTOA written out for you. Or in the case of this assignment, you would just need Ka, so that you do not have to always write out cos of A equals adjacent over hypotenuse. Now, for an assignment like this, I won't require you to write them out because it is all just cos the whole way. Once we get on to assignments that have sine, cos, and tan in them, I will require you to do that first step. But if you want to be a little bit lazy for after the first question in these assignments, go right ahead. Just make sure you're putting your adjacent and hypotenuse in the right places. Okay, you can start your assignment. Bye.